Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's weekly contest, maximize value of function in a ball passing game. The problem is very interesting application of binary lifting. We have discussed binary lifting in the past in this channel itself. If you have watched that video and you haven't thought in that direction during the contest, I would encourage you to pause and try it out yourself if you want. And I'm very sure you will be able to at least decode the problem if you have watched that video. If you haven't watched that video, that's fine. In this video, I will be assuming that you don't know anything about binary lifting, and as always, we will start from scratch and we'll look at how intuitively we can derive the solution from the problem. After the video, I would encourage you to watch the other video that I was talking about and solve that problem by yourself. So I would link the video in the description below. Feel free to check it out. So with that, let's get started. The problem states that you are given a zero indexed integer array receiver of length n and a integer k. There are n players, each have the IDs between 0 and n minus 1, and receiver of I will be denoting the ID of the player who receives the passes from the player with ID I, right? So there are some players, each player is throwing the ball to another player. Receiver of I denotes the receiver of the ball when ith player throw the ball, right? Now you must choose one of the n players as the starting player for the game, and the ball will be passed exactly k times. For the chosen starting player of ID x, we define a function fx, where fx is the sum of the IDs of all the players who receive the balls during the k passes. So for example, let's say you start with player with ID x, ID x player pass the ball to receiver of x, right? So f of x will be x plus receiver of x plus receiver of x, and so on and so forth up till k times. So it is given that there will be only k passes in the match. Now as you can imagine that there are n possible starting players, so you have to choose the starting player that maximizes the value of fx. So that's what the problem asks us to do. So let's take an example. Let's say receiver is 201 and k is 4. It means there are 3 players with ID 0, 1 and 2. When 0 throws the ball, it will be received by player 2. When 1 throws the ball, it will be received by player 0. And when 2 throws the ball, it will be received by player 1. And there will be exactly 4 passes. So you need to find out the maximum value of fx, where x can be either 0, 1 or 2. Now in this case they have said that let's say the game is started with player 2. So player 2 starts the game. So player 2, because player 2 is starting the game, you can see fx equals to fx starts from x plus receiver of x. So this is the value of fx. So you can see the current value of fx is 2. Now we have to do 4 passes. So if you do one pass from 2, ball will be passed to 1, right? So from 2 ball will be passed to 1, and because the new receiver is 1, you will just add 1 to your fx and the new value of x is 1. Now second pass come. So now ball is with player 1. So player 1 throws the ball, and you can see if player 1 throws the ball, player 0 will receive it. So player 0 received it, and the ID or the value of 0 is 0. So 3 plus 0 is still 0. So x plus receiver ID will be 3. Now the ball is with player 0. So player 0 picks the ball, throws the ball. From player 0, ball will be received by player 2. So player 2 received the ball. So in total the value is 3 plus 2, which is 5, right? And finally player 2 has the ball, and when player 2 throws the ball, player 1 will get it. So player 1 gets it, and the value would be 1 plus 5, which is 6. So this is the final value of fx after 4 passes, and you can try out any other possible starting player. You will not be able to gain more than 6, or you will not be able to get the value of fx greater than 6, and hence 6 is the answer, right? So hope the problem statement is clear. Now how to solve this? So hope you can understand the brute force solution itself. Let's say this is the configuration. Basically we have 4 players, 0 1 2 3 4. If 0 throws the ball, player 1 will get it. If 1 throws the ball, player 3 will get it. If 2 throws the ball, player 1 will get it. And if 3 throws the ball, player 2 will get. And finally if 4 throws the ball, player 3 will get, right? So we have given this configuration. Now let's say k is 3. In other words, we need to pass the ball 3 times and figure out the maximum value of fx, where x can be anything between 0 and 4, right? Now what is the brute force solution? Brute force solution would be try out every possible value of x. For each value of x, I will figure out what is the value of fx, and I will just take the maximum, and that will be my answer, right? Now how will this look in practice? These are the players 0 1 2 3 4, right? This array denotes the destination, or basically whom the ball is with after 1 throw, after 2 throw, after 3 throw, right? And this denotes the value of fx. So this denotes this value denotes that after 1 throw, if 0th player start the game, the value of fx would be 1, right? Similarly, after 2 throws, if 4th player start the game, the value of fx would be 10, right? Now how will you calculate these two? Okay, first of all, if you have these two metrics, you can see you want f of k equals to 3, and at k equals to 3, the value of f of x would be 6 7 8 9 10. It means if player 0 starts the game, fx would be 6, player 1 starts the game, fx would be 7, and so on and so forth. So in this case, you will just take the maximum across this array, and that will be your answer. So in this case, the answer would be 10, right? Now how will you build this array? Simple, like initially the first will be very straightforward. So it is exact copy of this, right? So player 0, if throws the ball, it will be at player 1 hand. So after 1 throw, the ball will be at player 1. Now after 1 throw, player 0 have started it, right? So after 1 throw, the ball is at 1. So in total we have 1 as the value of fx after 1 throw if player 0 starts it. Now if player 1 starts it, the ball will be at the hand of 3. So the sum would be 1 plus 3, which will be the value of fx, right? Similarly for 2 3 and 4, so let's look at 4. So if 4 starts it, player 3 will get it. So the sum would be 4 plus 3. So sum would be 4 plus 3, which would be 7. So fx would be 7, right? Now in the same fashion, you can now say, okay, after 1 throw, if we start from 0, the ball is at player 1's hand. So from player 1, we can do one more throw. So from player 1, one more throw will give you will end you up at 3. So you can simply go to 3, and what will be the score now? Score would be whatever was the score plus the new players that gets the ball. So 1 plus 3, which is 4. Similarly, from 1, you know the next player that will be getting the ball will be, from 1, you know the ball after 1 throw would be at 3. So from 3, the next player which will get the ball will be 2. So you know that after next throw, the ball will be with 2. So 4 plus 2 6 is the new score if player 1 starts the game, right? And similarly you will figure out 1 2 and 3, and finally take the maximum, and that will be your answer. Now what will be the time complexity in that solution? Time complexity would be the time complexity to figure out or to calculate these arrays. Now to calculate these array, what So first of all, you need to do this k number of times. So you will be calculating k of these arrays, right? For each array, what you are doing, you are simply iterating over all the players and seeing who is the next who will get the ball, right? And in the same fashion, you will calculate the dist and the fx as well. So for building each array, you are iterating over the player and then doing some constant operation. So for building each array, you are requiring order and time, and you are building k of these arrays. So in total, the complexity would be k into n. This will surely not pass the given time constraint because k is 10 to the power 10 and n is 10 to the power 5. So we need to do something better, right? Now, which of these two factors will you be able to remove directly? So notice that k is at 10 to the power 10. So we have to remove k. There is no other choice, right? So we need to figure out some way in which we remove k. N is fine. We need to remove k. What does that mean? It means we can't iterate over these array incrementally. So basically from 1 we should not calculate 2, 3, 4 all the way up to k. We should skip something if you want to skip k, right? Now from there we can see one interesting property. So C3, let's look at 3, right? What does this denote? This denotes that if 2 starts the game, after 3 throws the ball will be with 2. What does it mean? It means you can see if 2 starts the game, after 3 throws, 1, 2, 3. So after 3 throws, ball will be at 2, right? Similarly, this denotes if 2 starts the game, after 3 throws, ball will be at 3. So if 2 starts the game, if 3 starts the game and after 3 throws, ball will be at 3, and this denotes if 4. So let's start with this one. This one seems interesting. So if 4 starts the game, we need to find whom the ball will be after 3 throws. So we know that ball will be with 1. So 4 is the starting member and ball is currently with 1, right? Now let's say we need to find out after 6 throws, ball will be with whom, right? So we know after 3 throws starting from 4, ball will be at 1, and we also know after 3 throws, if we start with 1, ball will be at 1 itself. So after 6 throws, who will have the ball? 1, right? So basically we are saying that after 3 throws, ball will be at 1 if we start with 4, and we are saying that if we start with 1, after 3 throws, ball will be at 1. So in total, after 6 throws, if we start with 4, the ball will be at 1 itself, right? So basically from this array, we are able to calculate in a way the value at 6 or value at k equals to 6, right, from this array itself. And in the similar fashion, you will be able to calculate this array as well. We will look at how to calculate f of x with this array. Like, it is very straightforward in the very same manner, but we know how to calculate this very efficiently using this array itself. So just to reiterate, if you look at after 6th throw, whom the ball will be with if 0 started the game. So if 0 started the game, we know ball will be with 2 after 3 throws. So if 0 start the game, ball will be with 2 after 3 throws. Now we also know that if 2 starts the game, ball will be with 2 after 3 throws. So in total, after 6 throws, ball will be with 2 itself. So what we are doing, we are going here, looking at what the value here, and that will come here, right? So this will be the value of 2. Basically after 6 throws, if 0 starts the game, ball will be with 2. Similarly from 1, we know after 3 throws, ball will be with 1, and from 1 after 3 throws, ball will be again with 1. So basically after 6 throws as well, ball will be with 1, and in the same fashion you can compute others as well. So that's the basic idea. Now what we want is, we want to remove k, if you remember. So we want to compute, or we don't want to compute everything like from 1 2 3 4 all the way up to 6. Instead we just want to compute some of them. We want to compute x1, x2, x3, x4 and so on, such that we can merge all of them to get k, right? So basically, let's say k is 10, just an example. So if k is 10, one of the possible combination could be, let's figure out the value at 2, let's figure out the value at 3, or let's figure out the value at 2 and we'll merge 2 5 times to get 10, right? So in other words, we know whom the ball will be with after 2 throws. So we know that from 0 ball will be with 3 after 2 throws, and we also know that after 2 throws, if we start with 3, ball will be with 1. So from f of 2 we'll be able to compute f of 4, right? From f of 4 we will be able to compute f of 6 and so on and so forth. So we can compute all the way up to 10. So basically we just need to compute f of 2, or k, the value at k equals to 2, and from k equals to 2 we will be able to compute k equals to 10 as well easily. But one thing to note here is, we don't know the value of k in advance. Like when we are writing the program, we don't need the value of k, we don't know the value of k that will be coming as an input to the function, and how many operations we are doing is something that will come directly in the complexity. So if you remember, the complexity was k into n. So how many xi's we have here, that will directly come in the complexity. So let's say there are I number of xi's, so complexity would simply be I into n, right? So what we want to reduce I for all values of k. That is the problem. So we don't know which all x I will compute, because x will be something which is variable based on k, and we don't know the value of k. So if we want to do a generic algorithm, we want to optimize, or we want to find out xi's that will be able to give me the result for all values of k, and such that I into n will be minimum possible, right? So what will be the value of these xi's, like what will be the value of x1, x2, x3 all the way up to xi? I would encourage you to pause and try to think for a moment. So the value of xi's would be in the powers of 2. So that's the best thing you can do. Why? Because if you compute what will be the, or what will be the ball width, or who will be the ball width, if after 2 power 0 throws, who will be the ball width after 2 power 1 throw, who will be the ball width after 2 power 2 throws, who will be the ball width after 2 power 3 throws, and so on and so forth. Once you have computed all of this, you need at most log n number of these arrays for or log k number of these arrays in worst case, right? And with this log k number, if you merge some of this log k number of array, you would surely get k, right? In other words, let's say k is 5. So if you represent 5 in binary, it would be 101, right? Or in other words, it would be 2 power 2 plus 2 power 0, right? And you know you have computed 2 power 0 and 2 power 2 as well. So you can simply merge these two and get the required answer at k equals to 5. In very similar fashion, irrespective of what the value of k is, if you compute log n of these arrays or log k of these arrays, you can merge some of these to get k. That's what binary representation would mean, right? So hope this point makes sense. So basically now what we are saying is, we will only compute log k number of these arrays, and those arrays would be what will be the value at k equals to 2 power 0, at k equals to 2 power 1, at k equals to 2 power 2, and so on and so forth. And finally we will merge some of these to get the value at k. So we are building log k arrays, and for each array, if you remember, previously we took order and time, so that is still sufficient. So what we can simply do, if we simply build out these arrays in order and time, our problem is solved. So the complexity would be order n log k, and this is exactly what is called binary lifting. So basically we are lifting 2 power k times 2 power I times at a time. So basically if you look at this, we know okay, let's talk about the binary lifting approach, or why it is called binary lifting afterwards. But for now, I think you got the intuition that if we calculate log of these arrays, log k of these arrays, we will be able to solve the problem in order n log k time, given each array is still something we are able to build in order n time, right? So again, let's forget about this f of x array completely for now. Let's just focus on the value of dst, or whom the ball will be with after 2 power I number of throws, right? So let's start with this. So 2 power 0 is straightforward, right? It will be just 1 3 1 2 3, the exact same thing which is given. Why? Because it is 2 power 0 means whom the ball will be with after one throw. So we know that after one throw, 0, if 0 starts the throw, ball will be with 1. Similarly, if 1 starts the throw, ball will be with 3. So after 2 power 0 throws, this would be exactly similar to what we have been given, right? Now what about 2 power 1? So 2 power 1 is nothing but 2 power 0 plus 2 power 0, right? In other words, let's say if we know that, or we need to find out whom the ball will be with if we start with 0. So if we start with 0, the ball will be with, let's say, some xi, right, after one throw. And we also know whom the ball will be with if we start with this xi, right? In other words, in this particular example, we know the ball will be with 1 if we start with 0. So after 2 power 0 throws, ball will be with 1. And we also know what is the value of 1, or basically whom the ball will be with if 1 throws one time. So if 1 throws one time, ball will be with 3. So we are saying that from 0, after one throw, ball will be with 1. From 1, after one throw, ball will be with 3. So after 2 power 0 throw, after 2 power 0 throw. So in total, after 2 power 1 throw, from 0, ball will be with 3, right? So this value would be 3. In the same fashion, let's do this one more time to get this bit more clear, and then we will look at the other pieces. So from 1 we know that ball will be with 3 with 2 power 0 throws, and similarly from 3 we also know that ball will be with 2 after 2 power 0 throws. So from 1, after 2 power 1 throw, ball will be with 2, right? So this will be 2. And in the same fashion, if you look at this, this would be 3, this would be the value at 2, which is 1, this will be the value at 3, which is 2, right? And you can verify this with this graph as well. After 2 throws, if you start with 0, ball will be with 3. If you start with 1, ball will be with 2. If you start with 2, the ball will be with 3. If you start with 3, the ball will be with 1. And if you start with 4, the ball will be with 2, right? Now let's do one final thing. So we want to calculate 2 power 2. Basically, if we start with 0, after 2 power 2 throws, whom the ball will be with, right? So we know that if we start from 0, after 2 power 1 throw, the ball will be with 3, right? Similarly, from 3, if we do 2 power 1 throw, the ball will be with 1, right? So in total, if you start from 0 and do 2 power 2 throws, again, why 2 power 2? Because 2 power 1 plus 2 power 1 is equal to 2 power 2. So if we do 2 power 2 throws, ball will be with 1, right? and in the same fashion you can compute others as well. So basically you can see for each value we just need to look at this array whom the ball will be with, and we can just go to that person and look at if he throws the ball whom the ball will land at. So we can simply put that value here, and in the same fashion you can see if you do for 2. So if you start with 1, the ball will be with 2 after 2 power 1 throw, and if you start with 2, ball will be with 3 after 2 power 1 throw, so it will be 3, and so on and so forth. So you can do this and fill this entire array. So filling one array does take order n time, because we are just iterating over the array, and we simply look at what is the value at the index which is present at the previous element, right? Now once we build this, we know the distance, so this entire thing can be built in order n log k time. Now let's see how we can answer the queries, right? So let's get rid of all of these and let's put the correct values here, right? So this is how it will look like if you just keep on computing. So if you keep on computing, this denotes that after 2 power 4 throws, if we start with 2, the ball will land at 1, right? Now let's say k is 9, or for that matter let's say 12, right? K is 12. So if k is 12, you can divide 12 into powers of 2. What it will be? 2 power 3 plus 2 power 3 plus 2 power 2, or 2 power 1 plus 2 power 0. This will be the 2 power 3 and 2 power 2. This will be the value of 12, right? In other words, you need to merge 2 power 3 and 2 power 2 to get 12, which in turn means that you want whom the ball will be with. Let's just copy this array. So you want whom the ball will be with after 12 iterations, right? Now you know that if you start with 0, ball will be with some or let's say we want to merge this and this, right? So if you start with 0, after 2 power 2 throws, the ball will be with 1, right? Similarly, if from 1, after 2 power 3 throws, ball will be with 3, right? So in total, if you see from 1, after 2 power after 12 throws, the ball will be with 3. So you know the value of this, right? In the same fashion, you can compute all the other values as well. So this is an example where we merged 2 arrays. It may happen that you need to merge 3 or more arrays, or in other words, you have to merge log n number of arrays in worst case. So let's say k is 13 instead of 12. So in that case, this will be how k will be represented. So in other words, you need to merge these 3 arrays, 2 power 0, 2 power 2, 2 power 3. So you will just merge 2 of them first, and then you will merge the result with the other one, right? So hope this entire thing makes sense. And now what we are able to find out, we are able to find out whom the ball will be with after k throws in just n log k time, right? But if you remember, the problem asked us to find out the maximum value of the function, or we need to find out the fx. So let's just now calculate this as well. Calculating this is exactly similar to how we have done this. So I will just quickly go through this. So this is the destination, basically whom the ball will be with after 2 power I throws, and this is the value of fx, right, which is the sum of the index of all the persons or all the players whom the ball passes through, right? So again, 2 power 0 is exactly equals to this for destination, because we know that whom the ball will be with. Fx is a bit interesting. So in this case, we know that we started with 0, right? So and ball reached with 1, ball landed at 1. So in total, the value or the sum of the player IDs whom the ball has passed through is 0 plus 1, so it is 1. Similarly for this one, the value of the player IDs whom the ball has passed through is 1 plus 3. Basically ball was with 1 and it goes to 3, so sum is 4, right? In the same fashion you will just do j plus dst of j and you will get this array, right? Now once we have built the first array, the next arrays would be straightforward. We already know how to build this array from this array that we just saw before. In the same fashion we will build this array as well. How? Let's look at. So we know that from 0, or another let's look at one big example to make things a bit more clear. Let's say we know that we have built this array and this array already, and now we want to build the next array, right? So in the same fashion you can apply the same trick for building 2 power 1 array from 2 power 0 and 2 power 2 array from 2 power 1 and so on and so forth, right? So let's look at this example. So this says that ball will be with 1 if we start from 0, ball will be with 1 after 2 power 2 throws, right? And it also says if we start with 1, ball will be with 3 after 2 power 2 throws, right? So we know that whom the ball will be with, we can simply look at the final one and that will be the result. So in this case, okay, so I think this is something wrong, so this should be 3. I think you got the idea basically, but let's assume that it is there. I think I did something wrong there. So, or another, let's take the upper example. Let's say we want to compute this from this, right? Just sorry for this. So now we know that ball will be with 3 after 2 power 1 throw, right? And similarly we know that from 3 ball will be with 1 after 2 power 1 throw, right? So after 2 power 2 throws ball will be with 1 if we start with 0, right? So that we already know. Now what about this value? This value says that after 2 power 1 throw the value of fx, or the sum of all the player IDs whom the ball has passed through, is 4, right? This says that from 3 to 1 the sum of player IDs whom the ball has passed through is 6, right? Now what will be the sum from 0 to 1? You can say 10. Almost correct, but if you see 3 is computed, or 3 is considered twice. So let's look at this. Let's say you start with 0, right, and you do 2 power 1 iteration, right? So you reached here. Now you start, what will be the sum? Sum would be 0 plus 1 plus 3, right? Now you start with 3 and this time let's do it with curly brace. So you do 2 iterations. So in 2 iterations you reached here, right? And what all you have considered? Let's denote by circles. So this and this. Now you know that from here you will reach here, that's fine, but you want the sum, and what all you want the sum for? You want this and this. So if you look at the total sum, it will be the sum of ticks and circles. So this will be considered once, this will be considered twice, this will be considered once, and this will be considered twice. So this twice makes sense because 1 actually appears twice, but this twice doesn't make sense. And why it appeared twice? Just because if you start from, if you are ending your path here, so this end is also considered in this particular path, and you are starting your path from here, so this start is also considered in the next path, and that's where this is considered twice, as a ending and as a starting. So that's where you will just subtract the value of what is the middle node, or what is the end and the starting node was. So 10 minus 3, which is 7, and if you look, this is the value here, right? So hope now you know how to compute the value of fx as well. So in the same fashion you will compute all the value of fx, right? And as we discussed, whenever you get any k, let's say 13, you will simply break it into powers of 2. So in this case it will be 2 power 3 plus 2 power 2 plus 2 power 1, right? And you will just simply merge these three arrays. So we will not only merge the destination array, but we will also merge the fx array in the same fashion. The only difference would be the fx array would just not be sum, instead it would be a subtraction of the middle player id as well. So how would the pseudocode look like? The pseudocode would look something like this. So very similar, very straightforward. We will compute log k number of arrays, right? So this is the outer loop. We are going to compute log k number of arrays. So inside this we are computing what will be the value after 2 power I jumps. So dest ij contains what will be the destination or whom the ball will be with, and sum ij contains this, which is fx, right? Or the sum of all the players which ball has passed through. So as we discussed, dist ij would simply be whatever value is here, we will go to that index, and whatever the value is, we'll just copy it here, right? So if you look at it, it will be dist, you want to compute this, so it will be dist of I minus 1, which is 2 power I minus 1 at j, so it will be 3, and you will look at what the value was at 3. So at this array only, what is the value of 3, which is 1. So you will just compute it here, right? In the very same fashion, you will look at what's the value here plus what's the value here minus what is the value here, right? So that's the exact same thing we have done. Sum of I minus 1 dist of I minus 1 j, what's the value at this cell, what's the value at this cell plus what's the value at this cell, right? You have to compute both, and finally you subtract this because this was computed twice, in the start and the end, and this will give you the sum. You will keep on doing this and you will have all these arrays, and finally you will merge the required ones based on what the value of k is, and merging would be exactly the same algorithm. So if you have watched till this point, I would strongly encourage you to pause and try to code this entire thing by yourself and get it submitted as well, because that's the point where you understand what you don't understand in this entire algorithm. So next we're looking at the code. The code is very straightforward. As we have discussed, we will calculate the sum and the dist array. So we computed the value of 0 by hand. By hand I mean the dist of 0 of j would simply be what the receiver array that we have been given with, and sum of 0 of j, as we discussed, it will be j plus what the receiver array was. Now once we have the value at j equals to 0 or I equals to 0, or this 2 power 0, we can compute the rest of them by this algorithm. So we have if you see, we have simply coded this algorithm. Dist of ij would be dist of I minus 1 and dist of I minus 1 j, and sum of I minus 1 dist of I minus 1 j plus the exact same thing, right? And after that, based on what the value of k is, we will merge some of these calculated arrays. So we have initialized our final array that will be getting after merge is merge with j and j, right? Both distance sum. So it means that we are starting with j, and if we are starting with j, after 0 moves I will be at j. After 0 moves, the value of sum of all the player IDs that have passed the ball through is also j. Now this is what after 0 moves is, and you want to do 12 moves. So you will just now combine all these arrays. So we are just iterating over the bits. If the bit is not set in k, we will ignore that. Otherwise we have to merge that number in the array as well. So in the this final dist and final sum, and this merging would be exactly similar as this. So the merging would simply be final sum of j would be sum of I at final dist of j and plus sum of plus final sum of j. So in other words, it says that whatever the value here was, let's say this is the final sum, let's assume that this is final sum. So it means what it's saying is what's the value here is right, plus look at the dist of this and what whom the ball will be with. So basically it says that if you start from 0, after let's say x moves, you will be with uh, final dist of 0, right? So and you are now adding, let's say, 2 power 3, just an example, and after 2 power 3 you want to know what will be the value of f of d of 0. So you know that you will be reaching at some f of d of 0. So you can simply, let's say this f of d of 0 is j, so you can simply go to that j, look at the 2 power 3 of that j, and that will be your final destination. So now once you know this path, you can simply apply this exact same trick to get the sum. So sum would be whatever sum was here plus whatever sum was here minus this value, right? So that's what we have done. So what this sum is simply the initial sum, this sum is the new sum, and this new sum would be f this sum of I minus 1, sum of I, this is 2 power I, right? Let's assume. So the sum of I at f of d of 0. So sum of I at f of d of j, right? Basically 0 is replaced with j because we are calculating for j, and minus final dist of j, which is what is the middle point or what is the ending point of the previous destination, and the final dist would simply be dist of I at final dist of j. Now once you have done this, this final sum would contain the sum of all the players or fx for each starting point. You can just take the maximum across all of them, and that will be your answer. So hope you understand the entire thing. If you have any doubts in any of the piece, I am very sure if you rewind the video and watch that particular section, you will be able to get it. I will attach all the timestamps in the description down below so that you can go back and forth in the section you like. And finally, if you understand this, I would strongly encourage you to go through this video, which is finding out the lowest common ancestor in log n time. This is also exactly the same trick, which is binary lifting, which we have applied in this particular problem. And if you understand, I will encourage you to try to solve this by yourself without looking at the video. And obviously if you don't understand it, you can look the video and see how similar approaches are this. So you can use binary lifting anytime you need to do, or you can combine operations efficiently. So in this case, we are able to combine operations efficiently, and that's why we are able to apply binary lifting. If you are not able to combine the operations efficiently, we will not be able to apply binary lifting. So with that, I will end the video for now. If you have any doubts in this problem, feel free to post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up, and do subscribe if you haven't already, and share it with your friends so that they can also get benefited. And I will see you in the next one. Thank you.